MHP, welcome back to Algebra 2.1. This is Mr. Carlson, C-squared mathematics. We are now going into our third week of Algebra 2. What we're going to do today is start out with solving proportions, simple rational equations. That's going to be our main lesson. Why are proportions related to equations? I'll show you how can we simplify them. I'll show you. We'll do all that fun jazz. We're going to go through Bell Arc. I want to go through some homework quiz questions from functions. That was last week. Go through the objective, the essential question, the main lesson, summary, closure, homework. Let's do it. So, 3 questions for the homework quiz, functions. These are some of the questions that you guys missed on the homework quiz. It seemed to me a very difficult homework quiz. That's what a lot of students have been telling me. Unfortunately, there are no retakes for the homework quiz, but I still want to go through them because you will still see them on a test, which is going to be next week. So, it's still beneficial to go through them so that we know what to do, why we got it wrong, and we can move forward with the right answers. So, let's do this one real quick. I'm actually going to use this tool. I think it's a little bit better. Let's see if this one works a little bit better. So use the graph to determine in the functions domain, so that's A, the range, the x-intercepts, the y-intercepts, and then the missing function value. Okay, so first of all, the domain. Let's put that up here. So let's do the domain. Okay, what is the function's domain? Now, if the graph never approaches the, this is what they tell us this, never approaches the x-axis. The graph approaches but never touches the x-axis. That's what I should say. Does that matter when I want to find domain? It actually doesn't, okay? What I'm looking at is my x-axis, sure, but I don't care if it touches the x-axis. All I care about is the x values of this graph. So where does the graph exist, and does it cross any x values? Not that it crosses the x-axis. I don't care if it crosses the x-axis. What I care about is whether or not there are x values that can join with the graph on any given y value. In other words, is there x values along this dotted red line where the graph may exist? Again, not where it crosses the x-axis, but where the graph exists, okay? And so if we look at -8, well, -8 kind of gets really close to -8. It never approaches -8 on the x-axis. And then you start to see like, well, -4, it doesn't cross here, but you can still have a graph, a point there. So that's definitely true. And as I continue going, you start noticing, well, all these values will eventually hit this graph. What I mean by that is if this graph is going to go down forever and ever, it's going to continue kind of going more and more towards that way, right? It's going to continue going more and more and kind of expanding for, because there's an arrow here, infinity. Since it expands for infinity, what is my domain? Well, there's an arrow on this side, there's an arrow on that side, so my domain is actually -infinity to +infinity. Why do I use parentheses? Because you cannot equal infinity. Now also notice, this is what I see a lot of you guys do on the quiz. You guys are doing something like this, +infinity and -infinity. That makes no sense. You know why? Because we read math left to right. Since we read math left to right, especially on the domain, we read math left to right on the domain values. What does that mean? That means I start from the left. From the left. From the left. Is +infinity over here? No. So why are you doing it first? Okay? The negatives should always come before positives. Just like you read math left to right. The negatives come before the positives when we read it left to right. Okay? So that is my domain. Now, what is my range? I think that's what it's asking next. My range is something very similar. Instead of reading it left to right, what we're going to be doing is reading it bottom to top, or what I say, bottoms up. Okay, so bottoms up, so bottom starting with the negatives and going up. Where does this graph on the y-axis, where does this graph actually exist? Well, it exists literally everywhere. It goes everywhere, except right here. Okay, now obviously it exists down here and exists down there forever, right? So we can start that. We know that it goes down there forever, negative infinity. Notice how the negative is first, negative infinity. And then it goes all the way up, and then we start to see this. It never touches the x-axis. Some of you are putting just random numbers in. Some of you are like literally putting in like 7. What? That makes no sense. Okay, 7 is all the way up here on the y-axis. I'm only looking at my y's for the y-axis. Okay, literally 7 is all the way up there, guys. Does graph exist up there? No. Okay, so you're not going to put 7 because that doesn't make any sense. What you need to do is see where the graph exists on the y-axis. And it stops existing right here. Now, what value is that on the y? The value of that is, that's -1 right here. What is this? 0. And so 0 is where the graph stops existing. Now, it never touches the x-axis, but what we say is it approaches the x-axis. So since it approaches the x-axis but doesn't touch it, is it included or not included? It's not included, which means parentheses. So I'm going to put 0 and then parentheses here. That is my range. Now, I spent a lot more time on that because that's really where you guys got it wrong. When we go to these, like the x-intercepts, we pretty much know what we're doing with the x-intercepts. Is there any x-intercepts? I sure hope not. If it never touches the x-axis, are there going to be any? Clearly not. Okay. And then for D, any y-intercepts, there is one y-intercept all the way down here at the bottom. Or sorry, right here, not at the bottom. So let me erase this. There is one y-intercept. It crosses straight up at this value, my y-axis. Oh my gosh. It's like, it doesn't even want to, my y-axis at -1. So this point right here, it crosses, that point is y equals -1. Okay? Sweet. Now E, find the missing value. This is part E. Now f of 1. Now we need to know that this 1 means x. So we're going to be at an x value. We need to look at my x value of 1. Okay, so let's look at our x value of 1. So x value of 1 is right here. So then what we do is try to find where it conjoins with the y value. Because that's what we're trying to find. We're trying to find that point on the graph. Because what this is saying 1 comma something, and I want to find that something. What is that something? It's a y value. It's an output. That's why you say f of 1 equals this. It's an output, and you're putting in 1. So you're putting in 1, you're getting out something. But the only way to get out something is to look on the graph and see where it hits and what y value does this hit at. Okay, remember, this is 1 right here, number 1, okay? And it goes and hits this. Well, what's that value? -2. So what does this equal? -2. What's my point then? Let's finish it. My point is 1 comma -2. Okay, that is my actual point on the graph. Notice I have an input, 1, and I have an output, -2. Okay? Sweet. All right, that was that question. I know we spent some time on that because that one was really missed a lot. So let's spend some less time on the next questions. Okay, these questions, I'm actually going to go fast. I'm actually going to get rid of this one. I want to try back this one because I really like this one. It's a little bit more faster. Okay, so A. Let's do A. Okay, f of -2. What does that mean? It means, given this formula, I'm going to plug in negative 2 in there. So I'm going to do this actually pretty fast. So f of negative 2, and I'm going to plug in with parentheses negative 2 squared, and then plus 6 times negative 2, and then minus 6. Now, why is parentheses important? I'll show you why. If you do negative 2 squared on Desmos or on a calculator, what you're going to get is negative 4. If you do negative 2 squared on your actual squared on your actual Desmos or calculator, what you're going to get is 4. Now notice, one's negative, one's positive. Why? Because what this is saying, and I'll erase this here. Okay, what this is saying right here, guys, is negative 2 times 2, which equals negative 4. But what this bottom one is saying is negative 2 times negative 2, which equals positive 4. Okay, notice how what we're squaring is the negative here, but in this, we're actually not squaring the negative. Okay, we're actually just squaring the 2, and the negative just gets tagged on. Okay, that's really what we're doing. All right, so make sure you use parentheses. They are your very best friend. Okay, make sure you use parentheses, even if you don't know. Like, whatever. If you don't know, if you're like, I don't know if I need to use parentheses or not, just use them. It's not going to hurt. Okay, so this is positive 4 minus 12 minus 6, which equals a negative 8, and then minus 6, which equals a negative 14. Okay, let's go to B. So B, I am given f of x plus 3. What is f of x plus 3? What is that? Okay, I'm going to literally plug in x plus 3 and substitute it everywhere I see an x. Or in other words, I'm going to substitute it here where I plugged in the negative 2. So instead of plugging in negative 2, I'm going to plug in that. So what I have now is x plus 3 squared, and then plus 6 times x plus 3, just substitution, guys, that's all it is, minus 6. This equals this x plus 3 quantity squared is literally it twice. Why? Because if I say 3 squared, what does that mean? It means 3 times 3, which is 9. If I say 5 squared, what does that mean? 5 times 5, which is 25. Okay? Why is that important? Because the squared means 2 of the same thing. That's 2 of the base. So what's my base? In parentheses, x plus 3. So that means 2 of them. You should not be getting x squared plus 9. Okay, that is completely wrong. It's half right, but it's also half wrong. You should not be getting that at all. Okay? All right. So let's continue. And then I'm going to distribute this. So this is going to be plus 6x and then plus 18. And then minus 6 tagging on, chilling at the end. Now, what is this? This actually means FOIL. Now, FOIL, again, I'll remind you, is first, outer, inner, and then right here, last. That's what FOIL means, okay? So the first terms are x times x, and I'm taking it times because there's parentheses here, I need to multiply them. X times x is x squared. My outer terms is x times 3, which is plus 3x. And now I'm adding because we want successive terms all put together. Okay? 3 times x is the same thing, plus 3x. And then 3 times 3 is 9. So this is the first. This is my outer. This is my inner. And that's my last. That's how I get FOIL. That's straight up Algebra 1 review. Hope we didn't forget that. If we did, learn it now. And then I can combine a couple things like this, 18 minus 6. So I can tag on the 6x down here. 18 minus 6 is just going to be 12. So plus 12. Now I can tag on these x's here, and then I can combine my constants. Okay? So I have x squared. Nothing gets attached to that. It's by itself. 3x plus 6x is actually 12x. And then 9 plus 12 is 21. So this is my final answer. This is what I would be putting in Math Excel. Sweet. C, let's do C real quick. C, if I do f of -1, okay, f of -1, what does this mean? This means I'm going to plug in, or sorry, f of -x. What does it mean? I'm going to plug in -x into my equation. So instead of -2 here, instead of x plus 3 here, I'm not going to plug that in. I'm going to plug in -x. So in parentheses, -x squared, and then plus 6 times -x, and then minus 6. What does this mean? Well, if I square anything, can I ever get a negative? No, I never get a negative. If I take -x, if I take -x times -x, what do I get? Because that's what squared means, right? -x times -x. I get x squared, because x times x is still x squared, okay? But there's no negative, which means I'm going to take that and just bring it down, but with no negative. Now, does the negative go poofy here? No, it does not go poofy, just a -6x and then minus 6 on the end, because nothing's there to attach to it. Awesome. So those are the questions I wanted to go through on Beller. I do have one more on here, but I'm not going to go through it for the sake of time. It is that word question there. Some of you did miss that as well. But if you're personally interested in finding out what the answer is, then please email me and shoot me a message, and then I can get back to you and we can work through that problem. Let's erase. Like I said, this is the one that I'm going to skip just for the sake of time. It's actually a lot easier than you may think, okay? I'm actually just going to just go through it really briefly just so that you're good with it, okay? What this is saying is X is years after 1990. What does that mean? Whatever you plug in for X, it needs to be years after 1990. So if you want to know the deaths in 2000, how many years have passed from 1990 to 2000? 10 years, which means what are you going to plug in? X is 10. So with this whole problem right here, you're going to plug in X as 10, so f of 10. Now you're going to plug into the G one. If it says F, use F. Are you going to plug into G? No, you're not going to plug into the G. You're going to plug into here. So what it'll look like is just something like this, and then 10 squared plus 57,573 times 10, and then blah, blah, blah. Okay? For the next one, you're going to use G, so you're going to use not F, but then you're actually going to use this one, G, and it says also 2000, so you'll use G of 10, okay? Which means, same thing, you're going to plug in 10 everywhere you see an X. How can I do that? Calculator, Desmos, boom, and then you get your answers. The last one is just showing which one is a better description. Which one adequately gets this number, okay? Because, again, you're looking at 2000, right? You're looking at 2000. You're not looking at 2002. I don't care about 2002, okay? What I care about is 2000, because that's what I'm looking at, 2000, right? So then after you get those answers, you're going to look at the next part, and you're going to say, okay, which function better describes the actual number in the bar graph? Which one's closer? F or G? You'll just hit F or G. Okay? So a lot of you are like, really? That's it? Probably? Yeah, that's it. Okay? Again, this one will more than likely be on the test. Just saying. Let's continue to our actual lesson. Our actual lesson is this: solve proportions in simple rational equations. What does that mean? Well, first of all, we're going to use appropriate properties. What does that mean? It means identifying what we call the least common denominator. It means identifying what an equation actually is, what a rational equation is, what a fractional equation is. And then in the midst of that, we're going to try to answer our essential question. What are the differences? What are the differences between proportions and rational equations? I should put an S there. So what are the differences between proportions and rational equations? We're going to figure that out. right now. Okay, so this first example is just going to go through proportions. What are proportions? Great question, class. Proportions look like this. Maybe you remember in Algebra 1 where you had like the part and the whole, and you needed to kind of make a proportion to find like the missing side. That's kind of what a proportion is. But when you have a fraction equaling a fraction, if you want to say that, so a fraction equaling a fraction, and there is nothing else, like nothing else attached to it, meaning there's no like plus 7 out here, or there's no like times 8 right here, okay, or 9 or something, because the 8s would just go poofy. When there's nothing like that, then what I can do is really simple. I can just cross multiply, which means this is going to be 16 times x minus 4, because the 16 is going to be multiplied to the x minus 4. Now, what about the other side? The other side in blue here is just going to be the 8 and then times the 6. So equals 8 and then times, the 7, times the 7. Okay? Now, maybe you're wondering, well, does it matter if I start with the 16? What if I wrote it like this, and then 16, and then equals 7 times 8? Or maybe you wrote it like this, 7 times 8 equals, 16 and x minus 4. It's like, does it matter, Mr. Carlson? No, all of these are solid. Now, the only thing that I would say that you have to look out for is one particular problem. Remember, who is your best friend in math? Parentheses. So what if you did 16 times and then x minus 4 and then equals 8 times 7? You know what the problem here is? I'll give you one guess. Okay, the problem here is that when you do 16 times x minus 4, it literally is just 16x minus 4 equals 8 times 7. Is that what I want? No. No. I don't want that. I need to use parentheses. Okay? I need to use it. So please make sure you put your parentheses right there. They are, as I said, your very, 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 very best friend. Okay? So let's get started on our actual problem now that all that's taken out of the way. Now that I use parentheses here, okay? Cross multiply, I get this. Now, what do? Well, I just distribute, of course. So 16x, and then this is going to be minus 64. 16 times negative 4, negative 64, this becomes 56. Okay? I have 16x and then equals 120. Why? How did I get that? Guys, just normal problems, just normal linear equation. That's why we reviewed it literally 2 weeks ago. So this is minus 64. I'm going to just subtract it there. Or sorry, plus 64. I'm going to subtract it there. Add it there. And that equals 120 right here. And then divide by 16, of course. Divide by 16. What's my answer? X equals sort of. You can simplify this as a fraction. I'm actually just going to go straight for the decimal. 7.5. Okay, which is just 7 1/2, which is really just 15 all over 2. Okay, so if you wanted the fraction, boom, that's it. Okay, all right. Let's go to the next one. Oh shoot, I was expecting it to be down here. Silly me. Okay, well, I'm going to erase this. Let's go to the next one. Same thing, we're going to cross multiply using parentheses. Doesn't matter which one you put first, absolutely not. So I'm just going to do this one first, and my next one, 5b plus 3. Distribute, so this is going to be 5b minus 15 equals distribute. This is going to be 10b plus 6. Okay, I'm going to subtract the 10 over here, and I'm going to add the 15 over there. So this is going to be negative 5b. When I add the 15 over, this is actually 21. I divide by -5, divide by -5. So B equals -21/5. That is my final answer. I know I went through that pretty fast. I expect you to already know this linear equation. If you're given this linear equation, you should be able to solve it like that, like no questions asked. If you're struggling even a little bit after you get do the cross multiplication, if you're struggling even a little bit to just solve that, then we need to talk. Okay, that's a problem. That's not okay. This is something that's very fundamental to algebra, and I cannot continue to explain it step by step every single time. I won't actually, because then you're not learning anything. You're not actually taking that leap. So please know what I'm doing here, just distributing and simplifying, combining like terms, solving for my variable b. That's all I'm doing, okay? I don't know if Math Excel will want a decimal or not, but I'm going to give you a fraction. Keep it like that. All right, let's erase. Let's continue. Now get into our what we call fractional equations. What are fractional equations? I'm going to show you in a little bit, but here are the steps, and you should write them down. Multiply all terms by what we call the LCD. This LCD is also what we call, it's an acronym for least, or abbreviation, least common denominator. And I'm going to abbreviate just denominator here, DEN. So least common denominator. Fancy math term, but that's okay. And then solve the remaining equation. So there's an easy way and hard way to do this. I'm going to show you the easy way. And it's easy if you follow the steps. It can be very difficult if you do not follow the steps. Okay? So first off, the very first thing is I need to find my LCD. What is my least common denominator? Now this is also very, very tricky. Some students just really have a hard time trying to figure out their least common denominator because it goes into the very foundations of what makes a factor or what makes something divisible by some other number. So I'll give you a hint, okay? I'll give you a hint. Can 8 be divisible by 2? Meaning, can I divide by 9, 8? So can I take 9 divided by 8? Is 8 divisible by 9? No. Is 9 divisible by 8? Can I take 8 divided by 9? No. At least I can, but it doesn't give me a whole number is what I'm saying. And then this, of course, this is a fraction. It just doesn't show it. It is over 1, okay? It just doesn't show that. So these are all fractions here, and we need to multiply everything, all terms, the whole shebang, by the least common denominator. But what is that least common denominator? Well, if you don't know, and if you just are having a difficult time trying to figure out this LCD, a great rule of thumb that always works, always, just in case, is you multiply all the denominators together. That will give you at least a common denominator. Is it the least common denominator? No. Sometimes it is if you multiply all the denominators together, but sometimes it's just a common denominator, okay? And then you have to simplify the rest later. But in this case, now watch carefully, please watch. In this case, if we take all the denominators together, 8 times 7 times 1, we actually get 72. And this itself is actually my least common denominator, okay? That itself is my least common denominator. How do I know? Because the only numbers that 8 and 9 go into evenly, the next number out of my whole number line, that 8 and 9, the very first number that they both go into evenly is 72. But it just so happens that if I multiplied all my denominators, I also get 72. That does not always happen. So I hope you're following me there. That if you don't know how to find the least common denominator, the first number on the number line in which all denominators can divide into that number evenly, if you can't find that, then when you're in doubt, just multiply all the denominators together and then you'll get the common denominator. But in this case, we did the second. We multiplied all of them together, 8 times 9 times 1. We got 72. In this case, it just so happened to be my least common denominator. The first number that 8 and 9 can go into evenly, can divide into evenly. I hope that makes sense. We're going to now continue with the math. I'm going to take it extremely slow for the first couple examples, but I will start picking it up, okay? Because I don't want this video to be too long, and you can just keep rewinding if you need to. What does this mean? This means I'm going to take the 72 times this term. Yes, that is a term. X all over 8, that is a term. I'm going to erase all this, so I don't think it's necessary. Okay? Yes, x all over 8 is a term. I'm going to multiply to this all over on the right side of the equal sign, x all over 9, and I'm going to multiply 72 times -3. So let's do that here. What it will look like is this, guys. So 72, and then times x all over 8, and then I take 72, and then times x all over 9, okay? And then I take, now watch what I'm going to do here, minus, okay, I'm going to take minus 3, and then times, of course, 72. So times 72. Now it doesn't matter if I put the 72 on the right side of the -3 or the left side. It doesn't matter. You know why? Commutative property. It doesn't matter if I take 3 times 2 or 2 times 3. It still gives me 6 no matter what. Same thing here. Now, what is this? Now, notice these are all over 1, technically. Now, these are still all over 1, too. We just don't ever write it because they're both constants. We can just multiply them, yada, yada. They're not a fraction already, but these are. Now, watch what happens. What you can do is start simplifying this. There's 2 ways to do it. You can multiply the 72 to the x and then divide by 8. Okay? You can multiply the 72 to the x and then divide by 9. Okay? Or you can just cross-simplify, okay? Not cross-multiply, we already did that with proportions, but cross-simplify. So what does that look like? Now watch. How many times does 8 go into 72? 8 goes into 72 9 different times, right? So that means what I take is I divide 8 by 8, and I divide 72 by 8 to get 9. So that's my new number. So what do I have now? I get 9x. Now, what do you know? No more fractions. Okay, no more fractions at all. Okay, you following me? Like, that's what I need you guys to understand. That's why this is the easiest part. I promise you, this is the easiest way. All right, no more fractions at all. If you're struggling with that, you need to come on my Google Meets ASAP. ASAP. Okay, the very next day. This is something that's so fundamental that this is actually something that's taught in Algebra 1. And if you don't remember that, then I'll hopefully jog your memory. But if you're still like, I have no idea what you're doing here, then you need to spend quality time with me, okay? Joy, and it's going to be amazing. But what I did was I literally just took 72 divided by 8 gives me 9, and 8 divided by 8 gives me 1. Okay, I could have also written it like this, like I said before, 72 times x all over 8. And then I could just take, what's 72 divided by 8? 9. With an x attached to it? Yes, that's what I have here. So either way, you do the cross simplification or you multiply first and then divide. I don't care. I like to do the cross simplification because A, it's harder, and B, when I teach kids that way, they use it a lot more in their upper level mathematics, okay? And that's what I'm going to be doing. So here, how many times does 9 go into 72? 8 different times. And so 72 divided by 9 gives me 8. So that means 9 divided by 9 gives me 1. What do I have? I have equals 8 times x. Okay? Same exact process here, just divide by 9 instead of 8. How many times does 9 go into 72? 8 times. How many times does 9 go into 9? Once. That's it. Those are my new numbers. Okay? Everything's all over 1 now in the denominators, and that's what I want. All right? I don't want fractions. I want a nice, clean equation. In order to do that, I need to follow my steps. Okay? Negative 3 times 72 is going to be negative 216. Now I can just solve like normal. Now, parentheses may confuse you, okay? You shouldn't have them be confusing. It's really just 9x times 8x. So I can just subtract this 8x, subtract this 8x, which becomes x equals negative 216. That's my final answer. Okay? All right. If you don't understand that, that's okay. I'm going to do one more example. And then on example 4, I'm going to start picking it up a little bit. What I mean by that is I'm going to kind of go a little bit faster, maybe skip less steps. Your first step was finding the least common denominator. Your second step, once you found it, was to solve the remaining equation by multiplying all terms by the least common denominator. So this is our first step, this is our second step, and then the rest is mathematics. Let's erase and let's start picking it up here. Okay? So same thing, fractional equations, we just have a little bit bigger example. That's okay, we can still solve it though. First things first, what is my least common denominator? What is this? My least common denominator. Okay, I'm going to multiply everything by that least common denominator. What is it? Well, again, you can solve it one or two ways. The hard way, which is just multiply all the bottom terms, the denominators together, and then multiply everything by that big term. But look, watch guys, 3 times, this is all over 1 times 15 times 5, that's 15 times 15, that's 225. So technically a common denominator is 225, and we could do that, and that would ensure that we do get rid of the fractions and the denominators in the bottom. Absolutely, that does work. Here's the problem though, that's a freaking big number. Like, do I really want to do that? No, not if I have to. Now, by all means, you can, and you'll hopefully, if you're really good at the math and simplifying, you can get the right answer there. But it is very complicated. It can be complicated. I want to find the first number in which all terms go into evenly. Okay, so does 3 go into 15? Let's just start there. And we say, yeah, absolutely. 3 goes into 15 5 times, right? So 3 times 5 is 15. Okay, great. Does 5 go into 15? Well, yeah, Mr. Carlson, it does. Well, how many times, guys? Well, 3. 5 times 3 is 15. Give us a hard question, Mr. Carlson. Okay, great. Fine. What about 15? Does 15 go into 15 itself? If the answer is yes, how many times? Well, you'll say yes. 15 divided by 15 is 1. I thought this was hard, Mr. Carlson. Okay, does 1 go into 15? Yeah, once. Okay. 15 divided by 1 is just 15, right? It's itself. That's the identity property. Now, if we keep coming back to 15, what do you think the least common denominator is? 15, okay? Now notice this number is way smaller than 225. It's way smaller than 225, and it's gonna be a lot better to simplify it than the 225 number. Would it still work if we did 225? Yeah, if we simplified a lot of it, but we'd have to get our calculator out because we just don't sometimes know what 225 divided by 3 is or 225 divided by 5. That's going to be difficult. But this number right here, 15, every single denominator goes into 15 at least once. That's all we need. Let's multiply by 15 all over 1. What is this going to look like? It's going to look like this, every single term. So I'm going to take it step by step again, and then the next problem, what we're going to be doing is going to be a little bit faster. I'm going to skip some of these steps, okay? But first of all, what does this look like? I'm also going to drop the color coding because it takes a little bit longer. So 15 times 4x all over 3. That's what it looks like. Minus x times 15. Okay. So far so good. Notice how 15 is being multiplied to both. Equals 15 all over 1. This is all over 1. Times what? 15 times x all over 15. And then minus 16 all over 5, my original term, my original constant, fractional constant, and then times 15. And of course, this is all over 1 as well. Okay, now, what do we have here? Okay, these 15s right here, that 15, this 15, this 15, and this 15, is my least common denominator, 15, that I'm multiplying all the way through. That's what I did to all 4 terms. Okay, looks like the 4th of July. Oh my gosh. Or Spider-Man colors. I mean, to each his own. Now, what do? Well, I have to start cross simplifying, but I use division in order to do that. So just like the last example, how many times does 3 go into 15? 5 times. So 3 goes into 3 once, but 3 goes into 15 5 times. So I have 5 times 4x. Notice how both the denominators here in this term right here is just 1. That's what I want, right? I want just 1 because I want to get rid of the fractions. I want to solve this beast. I can't solve for x if I don't first eliminate the fractions, okay? So that's the first thing. The second thing I look at, well, is negative x times 15 is just straightforward, negative 15x. I just rearrange them there. And then this equals, this is nice and short and sweet. How many times does 15 go into 15? Just once. And so that means that just goes poofy and I just get x. Technically it's 1 all over 1 times x, but we're just going to leave x. How many times does 5 go into 15? 3 times. 5 goes into 5 once. 5 goes into 15 3 different times. So I'm left with 16, negative 16 times 5. What is negative 16 times 5? Negative 16 times 5. Sorry, times 3. Negative 16 times 3 is negative 48. Sorry. Negative 16 times 3 is negative 48. Now, let's start simplifying this. This is going to be 20x minus 15x. And then this just chills. This becomes 5x when I combine those. Equals x minus 48. I subtract the x over, So 5 minus x. 5x minus x is just going to be 4x. And then equals, because the x's go poofy, on the right side I just have negative 48 divided by 4, divided by 4. What do I get? I get x equals negative 12. Boom. Oh, it's a gross equal sign. I thought I could salvage it. I can't. So that is my answer. Okay, so I hope you're kind of getting the hang of it now. All right, what I'm going to do is the next example, I'm going to have you guys pause the video when we get to the next example. Try the next one yourself. Like, actually try it. I'm going to erase. But try this next one by yourself. Pause the video. See if you can get it. I know it looks a little scary, but it's the exact same steps. Okay. After you pause the video, I'm going to show you all the steps all together. I'm going to show you all the work, and you can copy it down when you come back. And I'm going to briefly go through the problem with you. And then we're going to get into our second to last section, and that is just simple rational equation. So pause the video, try to work it on yourself. All right, welcome back. So this is all the work that's for this problem. It looks like a lot, but I took it step by step again, so it's really not, especially if you skip some steps. But let's go through it really, really quick. I'm not going to explain everything here, but it is very, very similar to the previous couple examples. So first off, my LCD is 18 because 18 goes into 18 once, 9 goes into 18 twice, 3 goes into 18 6 times. So that means if I multiply everything by 18, that means it ensures that I get ones all down in the bottom, which eliminates my fractions. That's what I want, okay? And so that's why I multiply by 18 to every single term, even this big chunk guy right here, that little fraction here, and that big chunk guy right there, okay? Notice how I'm following my plus signs in between. This is technically plus, this is technically plus. I'm keeping my signs all the way through. It's all plus. Okay, when I multiply, I just cross reduce, cross simplify. That goes poofy, I get that. That goes to become 2 times 4. This becomes 6 times x minus 5 quantity. I distribute that, that becomes 6x and then minus 30. This becomes 2 times 4 is 8. And then I start moving stuff over. I move the 6x, move it over, that becomes negative 5x when it combines with this. And then I move the 6x over, the 6, subtract it over after I combine the negative 30 and the 8. I subtract the 6, I get negative 28 all the way over here. Divide by negative 5, divide by negative 5, negatives go poofy, and then I get 28 all over 5. Still an answer, even though it's a fraction, it's still good, okay? So if you're struggling with that, go through the last couple examples and then try to pinpoint where you're struggling so I can help you. I'm going to erase. All right, now here is the second to last thing that we're going to get to. I have actually a lot of these. Well, not a lot. I have some. I have about 4. And then I have a couple more practice problems after that. Okay, and so here are the steps. They're a little bit different. The first thing it's going to ask you is find what we call exclusions. Okay, I'm going to show you what that means. Find what we call exclusions, multiply all terms by the LCD, and then we're going to solve the remaining equation. And of course, then check. So what we just did in the last couple examples is really just 2 and 3. So our new steps are these steps. Okay? All right. So first things first, I'm going to be giving this problem. And I want you to notice something. What's different about this question? What's different about this question that was not present in the others? So the thing that's different is, and you should be thinking, think, look at the denominators, look at your notes. What's changed? You should be saying there are x's in here. In the denominator, there are x's, there are variables. Okay, that's what you should be thinking. And so if you thought that, congratulations, give yourself a pat on the back, a star, take a break, eat a brownie, whatever, okay? Great. Now, does that change our normal process? It may change our LCD, and we're going to get to that, but it does change one thing significantly, and that is exclusions. Now, let me ask you a very important question. Are you ready? Can you divide by 0? Try it on the calculator. Just try it. In fact, go to Desmos.com. Desmos.com. This presentation has been brought to you by Desmos.com. 8 divided by 0. What does it say? If you're saying, oh, 8 divided by 0, that's 0. Dumb, Mr. Carlson. Give us a hard question. Wrong. Okay, you are wrong. It's undefined. This is how we can identify undefined slopes, because it's undefined. You're dividing by 0. You can't divide by nothing. You can't take something and divide it by nothing. That makes no sense. Okay? You can't even take nothing divided by nothing, because it's still nothing. It's not nothing. Some of you are like, oh, 0 divided by 0 is just nothing, right? No, it's undefined, because if you can't take nothing in the first place, because it's nothing. So you can't take nothing divided by nothing. You can't take an operation with 0. So if you're saying 0 divided by nothing, you're trying to do an operation that doesn't exist. So that's why it's undefined. So let's go back here, ladies and gentlemen. Let's go back here and decide, what can't my denominator be? What can't x equal? This is what the exclusion is. What we're seeing is, with the first thing, I'm going to say, what can't x equal? Well, first off, it can't equal 0. And so because it can't equal 0, that is my exclusion. Now, there are fancier exclusions that we're going to get into in Algebra 2.2 and even a little bit at the end of this lesson, but you're not going to be necessarily quizzed on it. I'm just going to kind of show you around for those of you who are really interested in this kind of math. But for this basic simple rational equation, they're called simple rational equations, your exclusion is more than likely always going to be 0. So whenever Math Excel asks you what's your exclusion, you can guarantee it. It's just going to be 0. Okay, because there's an x down here. If I take 8 times 0, guess what? It's still 0. 29 divided by 0 is undefined. Can't have that. 4 divided by 0, undefined. Can't have that. And this is technically, it does have a denominator, by the way. it's 1, and since there's no x in there, I'm not taking 3 divided by 0. It's just 3 over 1. Okay? I hope that makes sense. That's the first thing we need to understand. Then after that, we go into our normal LCD. But again, it's going to be a little bit different here. What makes it different, Mr. Carlson? Well, you see, kids, there's an X. Does that change the process? No, it just changes the writing of it. What does that mean? What I mean by that is your process of finding the least common denominator is still the same. You just have variables now. So you're still going to find something that goes into a least common denominator is something that each denominator here goes into evenly. Do you understand? That it goes into evenly. Now, I'm not going to look at the 1 because the 1 is just a 1, but I'm going to look at the x and then the 8x. Now, if I did maybe 8, think about it. Just think. Okay, if I did 8, if I multiplied through, if I did 8, will that get rid of the x in the denominator, yes or no? Yes or no? You should be saying no, because 8 times 4, when I multiply it through, 8 times 4 will still be 32 divided by x. Does that get rid of the x? No. Okay, and if I multiply this 8 times 29, it does get rid of the 8 in the bottom, but does it get rid of the x? No. So what do? Very simple, guys. Just tag on an x. If you tag on your x, that's my least common denominator. If I tag on the x, guess what happens? When I multiply through this, does the x's go away here? Yeah, they go poofy. Do I have anything in the denominator here underneath the 4? No. That's what you want. That's what you want. So that's all math is following the rules of the game. I've noticed that when students are usually like really big gamers, like game board players, like they really like game boards, they actually pick up on math really, really well. You notice that? Some people say if you're good at music, you're really good at math. That's not true. I think if you're good at math, you're slightly good at music, but I don't think it works the other way around. However, if you're good at gaming, like game boards, okay, like actual game boards, not like Call of Duty and junk like that, all right, but games on the board, it's really just math because you're following rules. Like that's all it is. Math is all rules, and this is a rule because you have to think ahead, especially in Settlers of Catan. You have to think ahead in Monopoly. You have to think ahead in Ticket to Ride. You have to think ahead with Exploding Kittens or anything like that, okay? Even chess, you got to think ahead. If you're a good chess player, you're going to be good at math, okay? So what does that mean? That's my first step. This is my second step. I want to multiply everything together. This is 8x times 4 all over x. This is all over 1. I'm going to go a little bit fast here. So this equals 8x. Because I'm multiplying it to that. And then times 29 all over 8x. And then plus 8x times 3. Okay? What happens to the x's here? The x's go poofy. What am I left with? I'm left with 8 times 4, which is 32. The 8x's go poofy because that's technically over 1, right? And so what am I left with? I'm just left with 29. Okay? Notice how my fractions are disappearing? That's what I want. And then plus 8x times 3, that's just going to be 24x. I minus the 29 over, so that becomes 3. And this equals 24x divided by 24, divided by 24. So this equals x. X equals 3 all over 24. Each one is divisible by 3, so 3 divided by 3 is 1. 24 divided by 3 is 8. This is my final answer. Now, your fourth and final step is really to check against exclusions. Because if we get 1/8, but yet that was what it was solved, then it's a no solution. So if 1/8 is 1/8 is part of the problem, sure, that's fine if we get 1/8. But if we plug 1/8 in, we shouldn't, in for x, this x right here, and this x right here, we shouldn't get 0. We should get a number. If I plugged in 1/8 right here, the 8's go poofy and I just get 1, but that's okay, right? And if I plug in 1/8 right here, that's okay, right? Because it's not 0. So as long as this number, your final answer, is not part of your exclusion, in this case 0, then it is our final answer, unicorn time. Okay? All right. Now, let's go through another question. I'm going to go through that question with you, and then I'm going to try to give you one on your own. And then I may or may not go through the more serious questions. So let's continue. Let's erase. Okay, let's start out with finding our exclusions. Now again, they're actually really easy. What it means is, what can't x equal? And in this case, I can't put 0 in for x, because if I put 0 in for x, that becomes undefined. If I put 0 in for x there, 3 times 0 is 0. That becomes undefined. I don't care about that because there's no x. I don't care about that because that's over 1. There's no x. So we're solid with that. My exclusion is 0. Now, what is my LCD? My LCD, think again, is the number that every single term can be divided into. So it can't just be x, right? Because that has nothing to do with a 3 or a 6. So it has to be something x. But what is that number? Well, it's either 3. So if I do 3x, that gets rid of this one on the bottom, and that gets rid of that one, but doesn't get rid of the 6. If I take 3 divided by 6, it gives me 1/2. Does that get rid of a fraction? No. Which means I have to up it a little bit and do 6. Why 6? Because 6 divided by 6 is 1. It gets rid of a fraction. 6x divided by 3x is just 2. It gets rid of the fraction. And then 6x divided by x is just 6 because it gets rid of the x's. So this is my least common denominator. This is what I want. So I start multiplying through, and I told you guys I'm going to go a little bit faster here. You may even see me skip some steps. So if that's the case, okay, it's the exact same steps as the last example. Go through those last questions. I'll try to explain to the best of my ability, but I'm going to skip some steps here. Okay, 6x times this first term, 2 all over x, means the x's go poofy, which means I just have 6 times 2. Okay, plus 6x times 4x, or sorry, 6x times 4 is just 24x equals 6x times 2 all over 3x. The x's go poofy, okay? And then the 3 divided by, or the 6 divided by the 3 becomes 2. So not only do the x's go poofy when I do this, when I times it by this one right here, when I'm looking at this one, the 6x times this, not only do the x's go poofy because they're divided by, but the 3 goes into 6 2 different times. So really what you have is just 2 times 2. Okay? Again, 6x times this. Okay? 6x times that. The x's go poofy. And then you're left with 6 times 2 divided by 3. 6 divided by 3 is 2. So then you're left with 2 divided, follow my cursor, times 2. So 2 times 2. If that's confusing, if you can't even logically think about that, okay, that's okay. Don't freak out. You just need extra time to kind of let it mull in. All right, so go, again, back through the videos. Have Math Excel kind of go through the logical step for you. I just don't want this video to be any longer than it is. That's why I'm not going to continue to go through and show you step by step by step. Okay, I'm going to go a little bit faster. 6x times 25 all over 6. The 6's go poofy, but not the x, so I have 25x. Okay? So far, so good. I hope that's true. Okay. All right. Give me 1 second. Okay. This is going to be 12. This is going to be 24x. This is going to be 4 plus 25x. Subtract the 24 all over. Subtract the 4 all over. So this is going to be 8 equals, and then I subtract the 24 over here, and then becomes x. So that is my final answer, 8 equals x. So that's the first term. This right here is my my first step. Second step, this is my third step. My fourth step, what is my solutions? Well, is 8, 0. Okay, it's not, so we're good. Okay, I can plug 8 into this and still not get 0. I'm solid. So this is my actual answer. If you don't like how it's set up, then just switch it. It doesn't really matter. that's still your answer. Okay? Let's move on to the next one. And again, like I said, I'm just going to go adequately fast. We're just going through the exact same similar examples. It's just example over example over example. It's just, I'm going to go a bit faster. Okay? Find exclusions. There's actually no exclusions here, which is fantastic. So I'm just going to put none. The reason why there is none is because there's no x in the denominator. So there is no exclusions. This is solid. Check mark. We're good, which means I don't need to do 4. Okay? Now, what is step 2? Step 2 is multiplied by my LCD. What's my LCD? My LCD is that number that each of my denominators can go into evenly. And in this case, we already had this LCD before, but it's 15 because 5 goes into 15 evenly, 15 goes into 15 evenly, 3 goes into 15 evenly, and so forth. So I'm going to take this and multiply through to every term. So 15 times this, well, 15 divided by 5 is 3, so this is going to be 3 times 4x. And then minus 15x equals 15 divided by 15 is 1, so I just have x. 15 divided by 3 right here is 5, so this is going to be negative 5 times 16. Negative 5 times 16. Let's continue. This is 12x minus, not equals, minus 15x equals x, and then this is going to be negative 80. 5 times 16 is negative 80. Okay, this is going to be negative 3x equals x minus 80. Subtract the 3 or subtract the x all over, so this will become negative 4x equals negative 80. Divide by negative 4, divide by negative 4, so that means my x equals negative 20. Okay? Now, when I'm doing these problems, I honestly just skip right here. I can do all that in my head, and if you're that way, you're awesome. I mean, and if you're not that way, you're still awesome. It just takes you a couple more minutes, and that's okay. So if you're getting overwhelmed because you're not solving these questions as fast as I could or as fast as maybe someone else, don't freak out. It's practice. I've been doing this for a long time, over like 20 years, guys. So I haven't been teaching for 20 years, but I've been doing math for more than 20 years, let me tell you. Math has been my favorite subject for a while. So that said, I have a lot of practice. Don't freak out if you're just taking more time on these. It's okay. Okay, we have this example left to go. I'm going to do this again. Are there exclusions? There are, because there's x in the denominator. When there are exclusions, you know that there are exclusions if there's a denominator with x in it. If there's no x in the denominator, there's no exclusions. Okay? But if there's x in the denominator, there is an exclusion, and usually it is 0. Okay? Multiply all terms by the LCD. What's my LCD right here? There's nothing that 3 can go into 7 here. I know I need x. There's nothing that 3 can go into 7 here, so that means I do need to multiply the 3 times 7, and this is going to be 21x. So that is my LCD, 21x. I multiply through. 21 divided by 3 is 7, and then x's go poofy, so this is just 7 times 17. Plus 21 divided by 7 here, when I multiply it, is 3, and I keep the x, and then 3 times 2 is 6, so that means this is 6x. Okay? And then this equals 21x times this. Well, 21 divided by 3 is 7. The x's go poofy. And then 7 times 11 is 77. So notice how I'm going just a little bit faster here. Just a tad bit faster. 7 times 17 is 119. And then plus 6x, and then equals 77. I just have to subtract that over. This is 6x equals. And then when I subtract the 119 over, I actually get 42. So after I get that, 42, I divide by 6, and of course, I get 7 as my answer. Okay? Sweet. All right. Let's move on to some harder examples. I'm probably going to go, these are the only 3 hard examples I have. For the sake of time, because I don't want this video to be too long, I'm actually just probably going to go through this one right here. I'm not going to go through this because this is more like Algebra 2 stuff. Algebra 2.2 stuff. You're in Algebra 2. So I'm just going to go through this one right here. Okay, so this one, and then I'll skip the other slides. How do I do this? Now, again, this is start, so if you don't want to stay and watch this, just I do have a little bit more of this lesson. Just skip past this one example, because this you will not see on Math Excel. How do I do this? Well, you notice there's an x squared. I need the common denominator. There is an exclusion. Obviously, it's 0. It can't be 0. Now, what is my least common denominator? My least common denominator is really x squared, because x squared goes in x squared that many times. If I take x squared divided by x, then I just get x back. So I'm actually going to multiply everything by x squared. When I do that, what it's going to look like is this. X squared divided by x is just x times 3. Okay? X squared divided by x squared is just 1, so it's just 2. X squared divided by x is x, so this is just x times 4. So really I have this, and this is rather easy. I can subtract that. Actually, no, I'm not going to do that. Why would I do that when I could just subtract the 3? Subtract the 3x over, and so that means I get 2 equals x. So this is rather nice, simple. It's not my exclusion. That one is not scary. In fact, I'm probably going to do a next one, so I'm going to erase. But you see how it's just a little bit different because it has more variables. Now this one right here is going to be a little bit harder because it does have something like x minus 2. So this is something that we're going to do in Algebra 2.2, but maybe some of you honors kids may want to just stick around and figure out what to do. What's my exclusion? I'm going to do it really fast. My exclusion is actually when it equals 0. So I'm going to take the denominator, x minus 2 equals 0. I'm just going to solve it. When I solve that for x, I get x cannot equal 2. So that means if I plug 2 in here, I get 0, right? So 2 minus 2 is 0. I can't divide by 0, so that's my exclusion. If I put 2 right here, 2 minus 2 is 0, and it can't do the same thing. So that means my exclusion is 2 here, okay? What is my least common denominator? This one's tricky. My least common denominator is actually x minus 2. It's literally the whole thing, okay? And that's what makes this so tricky here, okay? Again, if you're watching this and you're like, what? We're going to be tested on this homework? It's like, no, this is not going to be on your homework. So you can skip this example and go to the last couple ones before I end the video. This is just for free for those of you who are really interested in math. What happens when I do that? Well, those go poofy, right? So the x minus 2s and the x minus 2s go poofy, so I'm just left with 5x. Now this 7 times x minus 2 is actually just 7x minus 14 when I distribute and everything. And then x minus 2 times this, the x minus 2's go poofy again, so this is just plus 10. So now notice I don't have any of my fractions here, and I got rid of my x minus 2's. So if we start solving this, let me subtract that over, so this is negative 2x, and this becomes negative 4, divided by negative 2, divided by negative 2, and then this becomes x equals 2. Now here's the problem. What was my exclusion? It was 2. So since it's not like you did anything wrong. We didn't do anything wrong here. What this means is if I plug in 2 right here, I get 0, and that's obviously undefined, which means if this is my actual answer, this is a no solution. Okay, this means this equation really can't be solved. We have to do something different to solve this equation because it's undefined. It's just no solution. There's no solution to this equation, and that's okay. All right. So that's what we did in step 4. We checked against the exclusion. Since my answer was the exclusion, it's a no solution. So this is my actual answer. Okay. So they're fun. I like these questions. We're going to do more about this in Algebra 2.2. So hold on tight. But let's get back to Algebra 2.1. Again, I'm going to skip this last example. Let's get back to Algebra 2.1. Just finish up some things here. Math Excel is going to ask you whether or not it's a conditional identity or inconsistent equation. Well, the last example that we did for strong Algebra 2.2, not 2.1, was a no solution. Honestly, guys, you really won't have that many like that. A no solution, an inconsistent equation, what that looks like is like something 0 equals 7. Okay. This is not an inconsistent equation. If I have x equals 0, some of you like to say that's no solution. Wrong. Okay. 0 is a number. Now, if you're thinking, well, Mr. Carlson, you said in Desmos that 0 was nothing, and you can't take nothing divided by something, or you can't take nothing divided by nothing because that's incoherent until you get undefined. So how can you say that something equals nothing? You can say something equals nothing. But you can't say something divided by nothing is something. Okay? And so really big number theory here. So what I'm saying is this is not an example of a no solution. A no solution is this. Okay, that is a no solution, where something clearly is not that thing. All identities, all real numbers are solutions. So sometimes you'll see x equals x. Sometimes you'll see 7 equals 7. Sometimes you'll see 1 equals 1. When that happens, all numbers are a solution to that equation. So you get parallel lines with that. That's called identity, or all real numbers, infinitely many solutions, and so forth. Conditional equation is just one unique solution. So that's x equals 0. That's x equals 1. That's x equals 7. Okay, and so forth. All right, that's that one, and that's that one. So just wanted to explain that because sometimes you all on Math Excel have something like that. Let's get to my final one. It's an application question. It's actually really easy, really fast. Get it fast because we're going to go through it fast. This whole problem, as you read it, you have to know one thing. It's pumps divided by time. So you have one pump that fills a tank 3 times as fast as another pump. So you have 2 pumps already. If the pumps work together, those 2 pumps work together, when we put them together, they fill the tank in 12 minutes. Okay? So if the 2 pumps work together as one pump, okay, think about it. The 2 pumps work together as one pump, they fill the tank in 12 minutes. How long does it take for the faster pump to fill the tank? So this is what we have. So one pump is 3 times as fast as another pump. And when we add those 2 pumps together, they give me a total of 12 minutes. Now notice, so 3 times as fast fills the tank 3 times, so this is times. So this is one pump, that's another pump. And when they work together as one pump, they give me 12 minutes. So this pump works 3 times as fast, that's the faster pump. This is the slower pump. Okay, I hope that makes sense. Now, how do I solve this? Well, my LCD should be, what do you think, guys? You should be thinking it's 12x. Okay, the reason why it's 12x is because when I multiply all of it together, I get rid of my denominators. The x's go poofy here, and then 12 divided by 3 is 4. Plus, x's go poofy there. 1 times 12 is just 12. And then 12's go poofy, and I'm just left with x. So 16 times as fast. How long does it take for the faster pump to fill the tank? 16 minutes. So this one is actually not that bad. It's actually very simple. It's very sweet, short, to the point. But you will see this guaranteed, by the way, on your homework quiz. I'm just going to tell you that right now. This one, if you made it to the end of this video, congratulations. You get an insider. All right? Homework quiz question right here. Easy. Okay, easy. All right. So that is all I have for you. Let's go through the summary. What did we do? We solved linear equations containing fractions. We solved rational equations. We solved proportional linear equations. And then we solved applied problems. Just one problem, but we still solved applied problems. Make sure you are doing your homework on Math Excel. Feel free to email me with anything. We do have a homework quiz tomorrow. If you do 100% on this homework, you get +2 extra credit points on the homework quiz. Awesome. Until next time, Algebra 2.2, this is C Squared Mathematics. Be sure to like and subscribe. I'll see you guys later.